Okay, next in topics 1.2, it's matrix operation. Okay, in matrix operation, it involves addition, subtraction, multiplication, and division. Okay, first we look at equal of matrix. Equal of matrix means that when we have two matrices A and B, okay, matrix A equal matrix B if Aij means elements in corresponding row and column in matrix A. Okay, and B is elements in corresponding row and columns in matrix B. Okay, example, let's say A is 1, 2, 3, 4 and B is 1, X, Y and 4. Okay, now if A equal B, so find X and Y. Okay, since A and B are equal, A and B is equal matrix, so the corresponding element, this is A11 and this is B11, they must be equal. Okay, in A12 and B12 also must be equal. So that's the answer for X is 2. Same also goes for A21 and B21. Okay, so A21 is 3 equal B21 is Y. So Y equal 3. Okay, so this is what it means by equality of matrix. Okay, next is matrix addition and subtraction. Matrix addition and subtraction. Okay, for matrix addition, let A and B be matrix of same size. Okay. So A plus B is equal Aij plus Bij. Means the corresponding element in row I and column J plus the corresponding element in row I and column J in matrix B. Okay, example, let A be 1, 2, 3, 4 and B is 5, 6, 7, 8. So both must be of equal size. This is 2 times 2 and B also must be of matrix 2 times 2. If both size are not equal, so we cannot perform matrix addition. So now A plus B is, so we add up the corresponding element in A and in B. So here add by 5. So number 2 here add by number 6, 3 and number 7 and 4 with number 8. So here we have 1 plus 5, 2 plus 6, 3 plus 7 and 4 plus 8. So answer is 6, 8, 10 and 12. Okay. Okay, for subtraction, same also goes for subtraction, whereby we have A minus B is same for corresponding element in A and in B. So we have 1 minus 5, 2 minus 6, 3 minus 7 and 4 minus 8. So answer is minus 4, minus 4, minus 4 and minus 4. Okay. Okay, next is scalar multiplication. Okay, next is scalar multiplication. Okay, for scalar multiplication, let's say C is a scalar. Scalar means real number. Okay, let A is a matrix of order m times n, and C is a scalar. Scalar means any real number. Scalar means any real number. Okay, so let's say we have A given by 1, 3, 4 and 2. Okay, C is a single number. Since it is a scalar, so it must be a single number. Let's say C, it can be positive or negative, it can be fraction, it can be decimal numbers. Let's say C is 5. Okay, find CA. So we have 5 as scalar multiplied by the matrix 1, 3, 4, 2. So we multiply scalar inside the matrix one by one. Okay, multiply it by each element in the matrix. So we have 5 times 1 is 5, 5 times 3, 15, 5 times 4, 20, and 5 times 2 is 10. That's it. Okay, so that is scalar multiplication. Okay, so for other examples, like bigger order of matrix, you can refer examples in the notes. Okay, the example given matrix of order in a big size, 3 times 3, 4 times 4, and so on. Okay, for my case, I just give you a simple example, matrix 2 times 2. Okay, same also goes for other matrix which is higher order, which is order matrix number of row and columns are big. For example, 3 times 4, 4 times 5, 5 times 6, and so on. Okay, the technique or the steps are the same. Okay, next is multiplication of matrix. Okay, for multiplication of matrix, let's say matrix A is given of order m times n, m number of row and n is number of column, and B is matrix of order n times p. Okay, so A can only multiply by B, or B can only multiply by A if number of column in A equal number of row in the second matrix. Number of column in the first matrix must equal number of row in the second matrix. Then only we can perform multiplication. Okay, and the answer is matrix of order here m times p. Okay, so how to perform multiplication of matrix? Let's say A given is matrix 1 and 2, and B is 3 and 4. First, find AB. Okay, first you must check order matrix for every matrix. Okay, you must check order of every matrix. Order in A is m is what? M is number of row is 2, number of column is 1. Here is number of row is 1 and number of column is 2. So here we have number of column in the first matrix equal number of row in the second matrix. Therefore, we can perform matrix AB. So the answer, you must have a matrix of order 2 times 2. Okay, so now let's see how can we perform a product of matrix. Okay, first we start with first row and first column. Okay, first row is 1. First column is 3. So 1 times 3 is 3. For the first number. Okay. Okay, and then followed by first row and second column. Earlier is first row, first column. Here, second is first row and second column. 1 times 4 is 4. Okay, next we move on to the second row. Second row, first column, which is 2 times 3 is 6. And second row, second column, 2 times 4 is 8. So this is the answer. Okay, where we have the order of matrix AB is 2 times 2. Okay, another example. Let's say we have C as 1, 1, 3, 5. And D is negative 1, negative 2, 1 and 2. Find CD. Okay, to find CD, again, we start with first row, first column. First row, first column. We get the number here. Okay, start with first row, 1 times negative 1 plus 1 times 1. 1 times negative 1 is negative 1 plus 1 times 1 is 1. Okay, for the next one here is element 1, 2. 1, 2 means that start with row 1 multiplied by column 2. Row 1 is 1, 1, column 2 is negative 2, 2. So 1 times negative 2 plus 1 times 2. Okay, and next one here is 2, 1. 2, 1 means that first second row in first matrix multiply by first column in second matrix. So we have 3 times negative 1, negative 3, 3 times negative 1 plus 5 times 1, 5. And here is 2 times 2. Second row, first matrix times second column, second matrix. Second row, 3 and second column. So 3 times negative 2 is negative 6 plus 5 times 2 is 10. Okay, so simplify this. So we have 0, 0, 2 and 4. So this is the answer.